the Triassic, and they survived this extinction. So this transition, we see a great change in the fauna, and this is where dinosaurs begin to diversify and rule the planet around 201 million years ago. So we also see this preserved in the footprints. So here you can see, this is kind of the range chart, late Triassic. You can see these different types of footprints. This is based on footprints in eastern North America. We need to make a new one for the west. And you can see certain taxa disappear, ichnotaxa, so tracks, disappear at the end of the Triassic, and you get certain types that are only evident at what we call the end-Triassic extinction, so where the terrestrial extinction occurs prior to that marine extinction. So we lose, in the late Triassic, footprints like Brachychirotherium, which is suggested to have been produced by Evosaurs, Apatopas made by Phytosaurs, Evozoum, which are possible dinosauromorphs or even sauropodomorphs. Anomepus, we see appear only in the early Jurassic. Same with Otozoum and Eubrontes. Anomepus is made by small plant eaters, Otozoum by big sauropodomorphs, so the big long neck, long tailed dinosaurs that you would see later in the Jurassic. And of course, large meat-eating dinosaurs, something like Dilophosaurus. So this is what the world would have looked like around 200 million years ago. I don't have one for a specific period of time when the Navajo Desert was around, but anyway, we're roughly in this area here. So you can see we're getting this sea forming here between the separation of Gondwana from Laurasia. So the Navajo Erg. So what we see is probably one of the largest sand seas on the planet, and it existed around 190 to 180 million years ago, made up of massive sand dunes. And this is kind of maybe what it would have looked like. This is a picture of modern Sahara with small lakes, and of course lakes and ponds in a desert environment are what we're going to be talking about big time, about the Powell track block and the discovery of these critters, the Tritylodons. So again, we're talking about these regions here. So this is during the Kayenta-Navajo transition. So basically what you see, and you see it beautifully here, especially in the eastern part of the park, where you get these intertunging sand dunes and river channel deposits. So they're kind of interfingered together as they're layered. So this is kind of another paleogeographic map showing the extent of the Navajo. Of course, we're pretty sure that it extended back over here into Idaho and as far as California at times. All of these little structures here, these indicate, the dot indicates the location of where the data was collected, and the line points in the direction which the dunes were flowing. So this kind of shows you the circulation of airflow, which way the dunes and the air was moving along the edge of the Proto-Pacific Ocean. So this is very close to sea level. Of course, this is basement rock of the Uncompahgre uplift, so middle of Colorado. You see all the beautiful granites and stuff. And you can also see, like you saw in the previous picture, you can see the main water flow. Most of the rivers were flowing from the southeast towards the northwest. You see that all the way through the Triassic and into the early Jurassic, through this basin. So looking at Zion National Park, I had to switch this name out. That used to say petrified forest member. It doesn't actually occur here, even though it originally got its name here in the Chinle. And also the owl rock does not exist. We now refer to this as the purple pedogenic beds. We found some pretty cool fossils in this park in the Chinle rocks. We can also add in the Kayenta, you can see tetrapod bones. We now have them here and here in the St. George area. We still don't have anything really in the Glen Canyon group from Zion National Park, but we can now add complete fishes and things like that at the top of the Whitmore Point in Zion. So, south of Zion, who was at the National Fossil Day today, checking things out? So you may have seen that spectacular skull on exhibit, brand new replica made by Rob Gaston, and it's of this specimen. This is close to the locality. where it was found, which is now a BLM wilderness area. And we managed to get this monster out because we somehow got our vehicles in close enough. This skull is close to 4 feet long, so if you didn't see it. So this is the replica, spectacular fossil. So this was found outside the park, but these rocks occur in the park. So these critters were swimming around in the Chinle around 220 to 215 million years ago. Here's a picture of the actual specimen. Here's the palate. You can see there's some beautiful teeth preserved. Rob Gaston redid the skull with all the teeth, which is awesome. Top view. So it kind of looks like a croc or an alligator, but it doesn't have the nostrils at the end of the snout. Instead, they're located in front of the eyes on top of the head. So those are the nostrils. And a couple more cool front views, the top of the skull. Look at that big, look at these giant conical fangs at the front of the skull for grabbing prey. And then they're blade-like and serrated along the sides, the edge of the skull. So really cool skull. Moving up section, important fossils found in Zion National Park. I had the privilege of being involved with Dr. Sid Ash, Dave Sharrow. We published on this specimen, which is a plant called San Miguelia. And San Miguelia was only thought to occur in the late Triassic. It was also thought to be at one time the first flowering plant, the first angiosperm. But in fact, it's not. It's still a problematic plant. So this now extends the boundary of this particular type of plant species into the early Jurassic. We also have footprints in the park. This is on the underside of a ledge at a site very close to here. And a couple of weeks ago, we collected this specimen here in Zion. Hard to see. This is the back end of a coelacanth skull and some other coelacanth skull bones. This is now in our lab at St. George, where we're prepping the specimen. Jim Kirkland and I are in the process of naming this new kind of coelacanth, which we have a lot of it at St. George, at our track site. Okay. All right, moving up into the Kanda Formation. Like I said, nothing really in the way of bones, but lots of beautiful tracks. This is a slab. This comes from the same slab in Collop Canyon. This was found nearby. And then this was kind of on the western edge of the park. You can see these 4 large toes. It's a very big footprints, and we're finding them all over southwestern Utah in the Kanda Formation, and they're not found anywhere else. We think this is probably a new footprint type, which we may eventually name. And then a spectacular track site on the hike, the subway hike. It's called the Subway Track Site. You can see all these huge Eubrontes footprints on these massive slabs. Yeah, that's covering. And these big slabs have actually fallen from the cliff way up. So pretty spectacular track site. I've never visited it myself. This is one that Connor, who just introduced me, recently documented and did photogrammetry on. And you can see these small footprints right here. These are animals that are actually walking on a sand dune surface. And of course, this is a fallen block from the cliff, and maybe the counterpart. So you're seeing both sides of the slab split open. This is another specimen that was collected near Snow Canyon, which is in our museum. It's another Brazil igneum trackway. So these were possibly made by our critters right over here, the Tritylodons. That's what's suggested that may have produced them. All right, so this is, and here's Connor's photogrammetry. Super cool. Nice to see this stuff coming out. Connor's big time involved with that work here in the park now, doing photogrammetry of the many documented sites in the park and looking for new sites as well. All right, so now we're moving east. I'm going to get to the meat of it. So on Lake Powell, this is a really rough strat section from one of Martin Lockley's publications. You can see the position of all of these different kinds of footprints, from the Cutler group, from the lower Permian, all the way up to the late Jurassic. You can find footprints. And again, we're going to be concentrating on this area. So, Lake Powell. So, John Wesley Powell in the summer of '69 named Glen Canyon. He actually made 2 trips down the canyon. This is John Wesley Powell here. And of course, now we have the Glen Canyon Dam. I would love to get a copy of this book. It's so hard to find, and it's full of pictures, but I've not been able to find a copy of it. I took a photograph on one of the boats that was at Lake Powell, that somebody had, and I'd look for it on